Hello there, our wonderful and esteemed viewers on this favorite mathematics YouTube channel, Mathematics by Abuzeno. That channel is specially created for you and I to come together to demystify mathematics and tackle the age-long phobia associated with this all-important subject, one topic at a time. I'm pleased to have you join us again today on another roller coaster of exciting, enlightening, and most importantly, fun way of learning mathematics. Today we are continuing on the topic geometric progression, which was introduced in the last video. In the last video, if you recall, we introduced the concept of nth term of an AGP. And from there, we looked at the various parameters that make up the formula. And recall the formula is given as Tn equals to A R raised to power n minus 1. Here I explained that Tn stands for either the nth term or the last term. A stands for the first term of the sequence. R is the common ratio, which I explained is obtainable by subtracting the first term from the second term or the second term from the third term. And the value n simply stands for the number of terms available in the sequence in question. We looked at some examples as well as introductory level, but today we are going deeper to see how this formula can really be applied. To start with, if you look at the formula, Tn equals to R raised to power n minus 1. If, for example, you ask to find the sixth term, that would be T6. That would be what? AR 6 minus 1 is 5. So that means for sixth term, we're going to have 5 and the power of R. So what about T12, for example? That would be AR, again, 12 minus 1, 11. So in other words, the powers of R are just one less than the number of terms. So invariably, if you have to find the 99th term, that would be T99, that would simply be AR 98. If you have to find the 1001 term, that would be AR raised to power 1000, which I believe is quite straightforward. So that's a very quick way of getting the number of the term of a GP, rather. So moving on today, without missing words, we are going to go straight into questions. So I have here on the board one question here. Given that (144, n, 18) are the first 4 terms of a GP. That's geometric progression. Find we are required to find, of course, first, the common ratio, and 2, the values of m and n. We start with this question here. So, given that 144, n, 18 are the first 4 terms of a GP. That means this is first, second, third, fourth, accordingly. So find the common ratio and then the values of m and n. So when you have a question like this in an examination, of course, there are some knowns and some unknowns, and naturally, you start from the known. Don't worry about the unknowns. Let's start from the known. We move from the known to the unknown. The knowns are 2, and they are the first term and the fourth term. So we list that as A is the first term, 144. And the fourth term, the term 4, is 18. These are the 2 facts of the question that we are setting up. From then, we recall, like I explained just a couple of minutes ago, that the fourth term is what? AR3 in formula. AR3 equals to 18. From here, the fourth term is 18. And the fourth term in formula is AR power 3 equals 18. Simply replaced by 144. So A is 144. Substituting that, we're going to have this. Hence, R cubed is 18 divided by 144. So R cubed then is actually going to be 1/8. That's R cubed. But we have to find the common ratio. And common ratio is going to be taking the cube root of both sides. And that's going to become 1/2 for that particular part of the question. And once you have our common ratio, we can easily go ahead and find our m and n values. Recall from the question that m is term 2, the second term. the second term. And the second term in formula is AR, just AR. That's AR power 1. And knowing that A is 144 and R is half, so it simply means 144 times half, that is 72 as our value for n. Then lastly, what's the value for n? N is actually the third term. And third term in formula is AR power 2. So A is again 144 and R is half. So don't forget to square the half because it says half square. So if you have 144 times half square is 1 over 4. So 144 divided by 4. That's the meaning of that. The answer is going to become 36. So in conclusion, our common ratio is half. Our second term, which happens to be n, is 72. And our third term, which is n, is 36. And that's the solution to that beautiful question to start with, which I believe you found quite interesting. Let's move on without wasting time to number 2. Number 2 is no less interesting, except that it's written this time around fully in words. We have that the second and fifth terms of a GP, that's geometric progression, are respectively 12 and 3, 2, 4. Find again the common ratio and the 10th term. Common ratio and 10th term. Okay, there we go. So you have this question patterned fully in terms of work problem, but it's pretty much like the previous one. All you need to know is that we have to start with the node. So the nodes are second and fifth respectively. So we are told that from the question we can derive it. Second term is 12 and fifth term is 3, 2, 4. This much we know about the question. So in formula, this implies that second term is AR and that is 12. And the fifth term is what? AR4, which is 324. So again, when we simply solve this, we can simplify this by saying AR is 12. Putting that here, this means AR times R cubed. That's the meaning of AR4. AR times R cubed. Because AR4 is AR and then R cubed. Knowing well that AR is actually 12, we're going to say 12R cubed equals to 3, 2, 4. So 12R cubed equals to 3, 2, 4. In other words, what's R cubed? That will be 3, 2, 4 over 12. I want to believe that getting it as straightforward as possible. So if R cubed equals to 324 over 12, what is 324 divided by 12? Let's do the manual mathematics here. That's going to be simply 27 going to divide. So 324 divided by 12 is 27. Hence, R is going to become what? The cube root of 27, which is 3. So the common ratio for this question is 3. Now, we've gotten the first part. We have to find the 10th term. However, we know that without A and R, we can't do much. We've gotten R, of course. What then is A? So even though A was not directly required, it's inevitable to get A. So to get A, we need to go to any of the equations. If I use AR equals to 12, I can then say that, okay, AR is 3 equals to 12. So A is going to become 4. So therefore, A is 4, R is 3. So now get the 10, 10, which is what we are required to get in part 2. T10 equals AR what? 9. AR 9. And A is what? 4. And R is 3 power 9. and that's the solution. You can go ahead with your computer or your device, calculator, an exam. Committed to have 3 to the power 9, they multiplied by 4. Please don't make the mistake of saying, which some students do the exam, to see 4 times 3, you not see 12 power 9. This is wrong. Very, very wrong. Okay, so that's basically the solution there. So if you actually do the computation, we're going to have as answer 78732 as our total answer there. So now we have the second question taken, and that leaves us with the very last one here to still see the application of the nth term of a geometric progression. The question goes thus: if k plus 1, 2k minus 1, and 3k plus 1 are consecutive terms of an exponential sequence. So find the value of k. Find the value or values of k. Okay. So here we're going to use a concept that is very, very fundamental to exponential or geometric progression. And what's that concept? That to identify as an exponential sequence or a geometric progression, we bring about the concept of common ratio. So that means for you to be a GP, you must have in existence common ratio. And what's common ratio is what? Second term over first term, which must necessarily be equal to third term over second term. So since they are consecutive, you can go ahead and apply by saying, okay, 2k minus 1 over k plus 1 on one hand equals 3k plus 1 over 2k minus 1 on another hand. So each of them represents common ratio. So from there, you can just take it by cross multiplying. We're going to have 2k minus 1, 2k minus 1 equals to 3k plus 1 and then k plus 1. Open the brackets, I'm going to have 4k squared minus 2k minus 2k plus 1. That's the full expansion here. And then I'm going to have 3k squared plus 3k plus k plus 1. That's the full expansion there as well. Collecting like terms, I'm going to have 4k squared minus 3k squared. This is minus 4k on the left hand side. And we have 4k here as well. That becomes minus 4k. Then plus 1 minus 1 equals 0. So I have fully collected like terms to the left hand side. And this gives k squared minus 4k minus 4k is minus 8k equals to 0 because 1 minus 1 is 0. Hence, we have resulted in a brand new topic again, quadratic equation. So solving this easily by factorizing, we're going to just have k bracket k minus 8 equals 0. Look at the question, we are given find a value or values of k. Now we can have more than one answer based on that. And in quadratic, we need to have two answers. So k from here is either 0 or k minus 8 is 0. Therefore, k can assume this value of 0 or the value of what? Plus 8. However, realistically, in conclusion, we say k is actually 8 because if we insert 0 in the questions, we're going to simply have 1 minus 1 and 1, which is actually a geometric progression. So the value that makes sense realistically is k equals to 8. And we therefore come to the end of the examples on the application of the nth term of the GP, which I think you found quite interesting and revealing. And you admit that this is a bit more technical than the previous video. This is how deep Python goes. I believe you found today's class much fun and interesting as I did. If you do, please don't forget to subscribe, like, share, and tune on your button so that you'll be the first to know when our next video shall drop, which shall be something on some of the first 10 terms of the GP. Thanks and stay blessed.